So for those of you who don't know me, my name is Deborah Melkin. I've worked as a DBA for 20 years. I've mainly worked with SQL Server, but I've done a little bit with some of the other relational databases. And I think the big thing and the reason I've been able to do that is because I know SQL. And I know T-SQL, so I can translate it to SQL, which are the generic stuff. So I've kind of figured out what I need to ask. So hopefully you'll if any of you are working with multiple databases, this will help you with that as well, and just kind of thinking about how you transfer that information over. Let's see, I'm a board member of the New England SQL Server User Group. We are the local user group for SQL Server in the greater Boston area, so in the Boston suburbs. So I'm up in New England. I'm a user group and SQL Saturday speaker, so I've done several user groups in the area and other remotely SQL Saturdays. I've been to several of them before. We've had to put them on hold. I'm looking forward to attending those again. I'm very proud of this one. I am an IDERA ACE class of 2020. So IDERA is sponsoring, they sponsor speakers to help make sure that they can get out and speak more. And so there have been some really great IDERA ACEs in previous classes. I think Monica may have been one as well. I'll let her speak to that. But there have definitely been some other great IDERA ACEs, so I'm very honored to be part of that. And let's see. This one I'm kind of proud of. If you've heard of PASS Summit, which is one of the largest SQL Server conferences that's held every year in the fall. Last year was in November, this upcoming year as well. Usually it's in November, I think. They have a contest, Speaker Idol, and I somehow won it this year. There's some great competition. So it's a 5-minute speaking. So yeah, so I'll be speaking for this upcoming speaker PASS Summit as a prize. I think it's a prize. Yes, it's a prize. But this is like the unimportant stuff, right? So here's the really important stuff to know about me. I'm the alto section leader of my choir. I usually do a lot of bluegrass jams. It's a lot of fun getting together with random people and making great music. I've been learning guitar as part of that, and I have a mandolin that I'm trying to get back to and not neglect entirely. And I'm kind of a big musical theater geek. If you want to talk about the Sondheim 90th birthday celebration that was on Sunday night, ping me afterwards. I'm happy to wax poetic about how awesome it was as much as possible. So that's kind of the basics about me. We've hit 1 o'clock according to my clock. So I guess it's time just to kind of jump full into the session. So thank you all for coming. So we're going to talk back to the basics, T-SQL 101. So what are our goals? And I'm kind of saying this more as a goal rather than as an agenda, because some of it, what we're going to do is I want to think about how we put things together. So when I was trying to think about how do you describe a goal like that, I went to a cartoon that I loved from the 90s, Animaniacs. My favorite character is Mindy, who is this cute little toddler who's left in the care of her trusty dog, Buttons. And in every episode, Mindy goes wandering around and she runs into people like these two gentlemen here. And she goes, "What you doing, Mr. Man? Why? 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 Okay, I love you, bye-bye." And she wanders off, leaving them to question, wait, what am I doing and why am I doing it? You know, essentially causing a bit of an existential crisis. And that's kind of what I want us to do when we talk about our SQL queries. Yeah, I'm including existential crisis with that as well. Some queries deserve it, but you know, we'll talk about that later. Or maybe that's the 201 version of this talk. But I want us to really think about that query and what is it doing and why are we doing it? Why are we writing the query that way as well? So that's kind of our goal. What you doing, Mr. Query? Why? And that's how we're going to build our queries and think about the different parts. So that's the what part. So what are the different parts that make up a query? The why part is almost more of a how, but it's thinking about how those different parts work together, because I want to answer not only what are they doing, but why that query? Why are we writing the query that way to get the answer to our question, to get that particular data set? And if nothing else, I want us to learn one new thing. So maybe it's something you hadn't heard of before, maybe it's a new concept, Or maybe it can just be a different way of looking at something that you already know and thinking about it differently, because I think that's a really valuable thing to learn. So when we talk about SQL statements, there are more types of SQL statements than what I'm showing here, but these are kind of the two main ones as you get introduced to SQL that I think we talk about often. The first are the data definition language. So these are the statements that create, modify, or delete database objects. Things like create table, alter view. They define our objects. The next one is data manipulation language, and this is our focus. So you'll also hear this referenced as DML. Sometimes people think the M is modification language. I think in earlier versions I made that mistake because you do modify data, but it's really about manipulating the data. And that's exactly what these do. These statements modify data. You could also hear them referred to as CRUD operations. I think I found that came more if you have more of a developer or a programmatic background, because when I work with databases, I don't hear it much, but it is an important thing. And I think that operator, calling it a CRUD operator, may help us if you're transitioning from that background. I personally don't like the term CRUD because it's CRUD. You think of it as garbage, and it really isn't. Luckily for us, it's an acronym. So let's break it down and think about what those pieces are. C means creating. So those are going to be our insert statements. R is read, and these are select. These are selecting data. U is update. So we're updating data, our update statements. And you can probably guess what D is at this point. D for delete, and we're deleting data. And if I think about it, these all kind of work together. It's almost a life cycle of data. So first you have to have data to work with, so you insert, then you read your data or you select, and then you realize that things aren't quite right, you need to make changes, so you update your data, and then you're done with it, so you want to delete it, and then you're out of data, so you have to create new data so you can read it, so you can update it, so you can delete it, so on and so forth. So I almost think of it as a bit of a life cycle in a sense. But these are the 4 statements that we're going to spend our time going through today. So now let's dive right into the syntax. So when I talked about CRUD, we start with C, we start with creating data. When learning SQL, we're going to start with the select statement. This is our basis. This is the basic statement, a select statement. It is the basis for everything else we're going to be doing. If you can write a select statement, you can write an insert, update, or delete. It really is that fundamental to what we're doing. And I also believe you're going to write more select statements than you will of pretty much any other type of SQL statement. You'll probably see in my examples today, there's very few things that I'm going to do where I won't write a select statement or execute a select statement first. It's really the building blocks of what we're going to do. So let's take a look at a basic select statement. There are 3 parts, although technically we only need that first line to be our select statement. So it's select a list of columns from a table or tables. It could actually be more, but right now we're going to focus on table or tables, plural, and a where clause, where some condition is being met. A select statement really just needs a select and maybe a constant or a variable to be a select statement. But as we're talking about the building blocks, we're going to talk about the 3 of these. The most important thing about a select statement, and actually anything that we do with our data, is we only want to select the data that we need. We don't want to select more data. We don't want to select too little data because then we have to go back and select again. We want to select the data we need and making sure we do that. So there are a couple ways that we use our select statement to limit the data that we're returning. The first one is going to be our where clause. And this is limiting the rows that are being returned. The next thing that we do to limit that is through our select, our column list. So it's returning the columns being returned. So we're kind of limiting it there. We don't always think that, oh yeah, it's limiting our data, but it is. Think about if you had a table with, let's say 100 columns on it, you only need 5. You just want to select those 5 columns that you need because you don't need those other 95 columns. So it's really selecting the data that you need. Well, now that we say we're limiting it rows and columns, well, we have to know what rows and columns are available to us. and that's where our tables come in. So which tables are we working with? Note that I'm saying table or tables, plural, so we can deal with multiple tables in our from clause. And this is where we bring in the concept of joins. So a join defines a relationship between two tables. It says what columns are these two tables related on? What values have to match in order for these to say these tables are related? There are three main types of joins. You have an inner join, you have outer join. There are three types of outer joins. One of these I write constantly. One of these I do once in a while. And one I have never sent out in production. I'm not saying it's a bad type of join, but as we talk about it, you'll kind of see why I've just never sent it out in production. But it's still very important to know. And then the final type of join is a cross join. For me, joins are one of the most fundamental things when you're writing select statements to understand and to get right. When I was first hired as a DBA, I really didn't know SQL. I'm still kind of shocked I got the job, to be honest, but I could explain a join and I could explain it well. And like I said, because I could do that, it really created that foundation so I could really learn how to write good select statements and write better SQL. So I'm a visual person, and when we talk about joins, I think being visual really helps. And I found this great image, and I'm giving credit to it, and I believe that as long as you're giving credit, I think the person who put this together said, just please give me credit for this. As you're learning joins, find this, print it out, stick it next to your computer, and use it, especially if you're a visual person, because I think this is a fantastic way to really see what these different joins are and what they mean and what data you're returning as you join these two tables together. So let's go into each of the joins. We're going to start with an inner join. You may also hear an inner join referred to as an equal join. So rows are returned when there are records in both tables based on the join criteria. So we have table A and we have table B. And the Venn diagram is perfect visualization of this for me because you can see that red section in the middle where it overlaps. That's what gets returned for an inner join. It's the data that exists in both tables. Next, we have a left outer join. So the first of the three outer joins. So records are returned from the left table and just the matching records that are from the right table. So if we look at our visualization, we see table A, we see the portion that overlaps between A and B, that's what's highlighted. And anything in B which isn't matched remains unhighlighted, so that's not going to be returned. So it's everything from A and then just the values from B's where there is a match. Now, a really important concept, we're talking about left and right. Well, how do you know what's left and right? I see words, right? Because that's what's written here. So if I go here, and here's how we determine what it is. Oops, I always do this wrong. There we go. Look for the word join. The table that is to the right, this is your right table. The table that is to the left, or in this case, right above, table A, that's your left table. It really is that simple once you think about it, because otherwise, well, how do I know what's left, what's right? Find the word join, find where the table is in relation to the word join, and that's how you're going to find out if it's your left table or your right table. So the next join after this, we talked about left outer join, that's next is our right outer join. And it is the exact opposite of our left outer join. Records are returned from the right table and matching records from the left table. So here, table B is completely returned, everything is highlighted, and just the portion of A that overlaps with B, that's the highlighted. So everything from B and only the records from A which match. This is the join that I have never set out in production. I may have actually rewritten it because a lot of times when I write, everything comes out, it's almost, I think I have to do it this way, to the left. So the right join, for me, figuring out the logic of which table's left, which one's right, especially depending when I have a lot of different tables involved, it can be a little bit confusing. But you have to understand what a right outer join is. It's not just that it's opposite of left outer join, but we need to understand how it works because that plays into our next join, full outer join. So this returns records from the left table and the right table, regardless of where there's a match. Another way to think of a full outer join is it is your inner join, it is your left outer join, and your right outer join all combined. So you can see we have the two tables and everything is highlighted, regardless of whether it's overlapped in the Venn diagram. Any questions on that quickly? I know I'm going to go into demos and that may make things a little easier to understand once we get there.
I think we're good for now, Deborah. You could.
All right. All right, so maybe we'll see what happens when we get to demos. So the last type of join that we're going to talk about is a cross join. You'll also hear of this as referred to as a Cartesian join. So essentially, we're returning a record set for all the combinations of records on both tables. So if we take this image and look a little closer, we can see our table here has 5 columns, and our table over here, oops, hit the wrong combo, has 6 columns. And when we look at the combination, we can see that for every column here, first, we see 1 row for each in the table 2. And again, we see it here for second, and if we had more, you'd see it there too. So it's creating a Cartesian product. So a combination of all the records on those tables. So there's one more thing I want to kind of go over before we get into demos of looking at select statements. And that are a couple other pieces to our select statement that you'll see commonly. Well, these first 3 lines we've already looked at, select from where. The next one that we're going to talk about is a group by. And we often associate these with rolling our data, our record sets that are previously returned. And usually we use it with aggregations like sum or count or average. But essentially it is taking our select from where statement and rolling up those results to a certain number of columns. Then we have our having. And I like to think of this as the where condition. We tend to use it for aggregates, but it's really the where condition on our group by result set. So you can't have a having clause without a group by. And the last one is very important, and that's an order by. This is the sort order for our result set. If you need data returned in a given order, you must use the order by. Do not rely on any natural ordering in your table because you may think it's supposed to be ordered by something. There are cases where that's not going to be what you get. So if you want data sorted in a particular way, you need your results in a particular order, always use your order by. So at this point, let's jump over and let's look at some demos of the select statements. Right now, I've decided to use Azure Data Studio for my demos. Today, I do have these if you're still using Management Studio, so you'll have both versions available to you. I wanted to try Azure Data Studio. This is kind of new for me too, because I like being able to have comments. Like this first comment here, where we're talking about a select statement. I'm actually showing you a shortcut. And when I did my test yesterday with everyone who's presenting today, first thing they did is say, Deborah, are you doing a select star? I'm like, but there's the comment, don't do this in production. So here's why. We write select star all the time, but what it is, it's a shortcut. It's essentially saying, I don't know what all the columns are, or I really don't feel like listing all of the columns out right now. So just show me all the columns that are available to me. As we were talking about, when you do select statements, you want to choose just the data that you need. So this is one reason why you don't want to use select star. The other thing is if you use it in production and then you make a change to a table underneath, maybe you added a column or you got rid of a column, your application is probably expecting something that's not going to be there, or it's not expecting it at all, and that could create, you could break the app and that would be bad. So we want to avoid those sort of things. But let's say this is brand new. You guys don't know what my person is in this person table here. So I'm going to run this cell, and I'm running it for something very specific. I'm running it for person where a specific last name is Prince. And we can see right here, I have one person who has a last name of Prince. I have a very small data set that I'm working with here. And now we can see all of the columns. One thing to point out, if you're new to working with SQL Server, in our from clause, you'll see this DBO dot. DBO is my schema, and then my person is the name of the table. So I'm using a schema dot table format here. I'll try to point out some of those others when I get to those. So right now, this select statement, I now know what all my columns are. So let's move down and let's try a different version of that instead. Select all my column lists from dbo.person where last name equals Prince. I ran that, and now I can see one row affected, and it's my same data set. So now let's find a different way to select from everything. I'm doing a very specific, I want to just search for that using my where clause for one specific value. I'm going to change that. I want to select everything from the table. Well, I happen to know my person ID starts at 1. This is knowing my data. So for just demo purposes, I'm going to say anything where my person ID is greater than 0, which should pull up everything in my table. So now we can see what we're going to be working with today. And I have 6 rows returned. And we can just see a couple different people that are available to us. And I want to do a similar thing for another table that we'll be working with, an account table. And I can tell you that I have less than 10 accounts here, but I'm doing a similar thing just for demo purposes where account ID is less than 10. And we can see I have 7 rows affected, and we can see I have 7 accounts, and we can see some of that information. So now that I have 2 tables to work with, let's jump into joins. So we're going to start with an inner join. So I want to find out, for this data that we're seeing above, I want to find out the name for my primary contact person. So a couple other things I want to point out in this query is you'll notice this syntax here, as a. I'm doing a very extreme shortcuts, but what this is called is creating a table alias. So now whenever in this query I want to refer to my account table, you'll see a dot. And this is going to tell me that I'm pulling this data from my account. And I'm doing a similar thing for person where I'm using P as my alias and P dot. And I'm also here, I'm creating what's called a column alias. So instead of saying a full name returned to my columns and my result sets for my column, I want to have it returned at and have that column called primary contact person. But notice my join clause, I'm doing an inner join. And when you write inner join, the word inner is optional. I tend just to say join, but you can definitely say inner join, and that works just as well. If it helps you understand which join you're using, please use it. That's one of the most important things is you want to be able to write code so you can understand what it's doing. Because I think that'll also help you prevent making mistakes and really making sure it's clear what you're trying to do and what you're trying to return. The other part of this is my on clause. So now I'm saying what 2 columns I'm joining this on. I have a primary contact person, and I'm joining it to my person ID. So I ran this query, and I have 7 rows returned. And I can see here, my column is now called primary contact person, and the full name is being returned. So I can now see who the primary contact person is for each of these companies. So now let's change this. I want to see the name of the primary contact person. I'm going to make one small change to that query because now I want to find out the alternate contact person. So everything is the same except for my join criteria. So instead of primary contact person, I'm now using alternate contact person. So I'm running this statement. And wait, I just got 1 row. There were 7 here, 1 here. But notice this is why. If we go back up and look at our results, this is all from the account table. there is no value for our alternate contact person ID. It's a null. So this means I don't have that data. And partly, there really is no data. Null is the absence of a value. But it's also saying I don't have anything to join. I don't have a match. So an inner join, because data on both tables has to exist for it to be returned, I only have one account which has an alternate contact person. That's why I only have one row returned, excuse me. So now let's move into the concept of the outer joins, because that's where we're saying the data doesn't have to exist and we can account for that. So I'm taking this same select statement, and instead of the inner join, I'm going to use a left join. I can put the word left outer join, and that is also an acceptable way to write this. I tend to write left join. But notice the join clause is the same. This is the exact same query. I just changed inner to a left join. And when I run this, I now have 7 rows returned. But only one of them has data for where the data matches, because I only have one record which has an alternate contact person. And now I can see that information. Now I said the right join is the exact opposite of a left join. So let's take a look at that quickly. Same query, but I changed the word left to right. And when I run this, I have 6 rows affected. We had 7 before, and now we have 6. Well, why is that? We had 7 accounts, but now we're not looking at based on the accounts, we're looking at it based on person, because we want everything from the person table returned and only the information where it matches on the account. So because of that, we can see I only have one row where we have information for accounts because only one person is an alternate contact person. But now I can see all the other people in my table, but because there's no account that they're an alternate contact person for, the data is being returned as null because there's an absence of a value. Any questions on that so far? Anything pop up?
Nope, I think we're good.
All right, so now we can continue with the full outer join, which, as I said before, is a combination of those 3 joins we did before, the inner, the right, and the left joins. So now I want to show pretty much all the person and count information, but we're going to keep our join on the alternate contact person ID. Note when I say full outer join, the word outer must exist. For right join and left join and inner join, you can leave out the word inner or outer. Full outer join, you need to use the word full outer join. So same query, just changed my join type. And we have 12 rows being returned. Well, think about that. We had 7 accounts, 6 people, but there's an overlap with one person for the account, which is why we have 12. So here we have the 6 accounts where we don't have an alternate contact person. We have 1 account where there is an alternate contact person. And then we have the other 5 people who are not alternate contacts. So now we can see all the information from 2 tables together. So this gets into, well, what would you use a full outer join for? Some of the other ones are a little more self-explanatory, but what can you get from a full outer join? I think of it in terms of writing a report. Sometimes you may want to find out what data is missing, but this one we can present our data that we just found in a way that has meaning. So I'm getting a little fancier here with my columns where I'm using a case when statement to say, based on conditions, I want this value returned as my column. And I'm creating a column list essentially here between these two, but it's a full outer join using the same criteria we just looked at. So when we look at the results, I'm still getting 12 results returned, but now I have a column list that makes sense and it's telling me a little more information than I would have had before. So it's just finding a way to present that information in a different way. Especially if you're doing 2 comparisons and you're using a full outer join, I think a lot of time you're trying to find missing information. Here I decided to use it to show a bit of a report.
Deborah, I don't mean to
Yes.
interrupt you, but I have a couple people asking a question on the example you did right before this.
Yes.
They would like to know why 6 rows were returned. Was there one row that had 2 of the same name?
For the right outer join, there were 6 that were returned.
That one right there, looks like.
Okay, so this is the right join. So there are 2 tables involved. So we have an account table which has 7 rows, and we have a person table which has 6 rows. So the right outer join says I want all of the rows from my table on my right. My table on my right, let's see if I can get this correct, is my person table. This has 6 rows. So in a sense, this is turning this into my main table. So I'm returning all 6 rows from my person, and then only the data from the account table which matches, because my account table is the one on the left. So we're only getting 6 rows because there are only 6 rows in the person table. The account had 7, but we're not caring about all the account. It's really based on everything in the person table and then the data that matches on the account. Does that make sense? And this is why joins are so critical to understand. It's like, wait, why are my numbers off? It's remembering what table am I getting all the information from? And here's person.
I think that works, Deborah. We just didn't want you to go too far into the next explanation without following back up on that.
No, this is a perfect time because then I'm bringing in the cross join, which is kind of a little different because again, this one is we're creating pretty much a straight line between our 2 tables and saying, I've got 2 tables. You're almost taking the data from the 2 and you're matching it across in a single line. And that may be one way to think of it. A cross join is kind of doing the opposite with that. So let's move down to that. So cross join, I'm going to use an example from a previous job that I worked at where we did software for hedge funds. And one of the things we had to deal a lot with was currencies. So I'm going to show you a sample currency table. I don't have a lot in here. I just threw some just a couple currencies, 6 currencies, and the conversion rate to US dollars, because I don't know if it's still true, but at the time, if you're doing anything with currencies and converting currencies, the way we got our information, at least, it was the currency's conversion to USD, and from there you had to convert from USD back to the other currency. So it was a couple steps. So what we did is we created cross currencies. So I would use a cross join to start. And so this is building up to that point. So notice our from clause, we have from currency, and I'm calling this first one left currency because this is going to be our table on the left. We're doing a cross join to the same table, currency, and I'm calling this one right currency. So now we can kind of keep what's on the left side and the right side. Notice what's missing here. There's no on clause to say these 2 columns are related to each other. And that's kind of a key thing because a cross join is a Cartesian join. So I want to show all the relationships between the rows. So I have 6 current rows in currency, and notice there are 36 rows being returned because 6 times 6 equals 36. And here you can start seeing some of that information where you can see that where you see the duplications, essentially. So for USD, I have a match for all of 6 records, and you see the same thing here for Euro and British Pound and so on. So this is where I started creating the cross currency. So now I'm taking that same query, I'm getting a little fancier with my columns so you can actually kind of see how I'm doing, what the currency conversions would be and the calculations. I am adding a where clause because I don't want the currencies to equal each other. USD to USD is going to be 1. I don't want to see that in my result set. So when I run this, we can kind of see how those cross currencies go. I can see my USD to Euro conversion, and I have my description here. I can see the different rates. You know, something like Euro to British pounds, I can see this is how you go Euro to British pound, and this is how you go pound to Euro, and so on and so forth. Now, let's say I don't want to see all of that. There's something specific I'm looking for. So this is where understanding what tables on my left and what table on my right matters. And I'm using it for a cross join, but you'll also see where it could apply for the other outer joins as well. Notice my where clause. I'm adding this line where my left currency is euro, right? Equals euro. It's the same query that we're adding before, but I'm just adding on to my where clause. And we look at the results, I'm only showing 5 because I don't want to see euro to euro. But notice here, I want my left currency to equal euro. And I happen to know when I created that, this is my left currency. So I'm only returning records on the left side where it matches. And if I reverse that and say my right currency code equals 0, notice here, it's now the right. And so if you can start playing with that, you start seeing how this can apply to other things, like when you have outer joins, left joins and right joins. When you're filtering on the right table, but you're doing a left outer join, the right, everything that's being pulled out in your where clause means that now that I have how my left join and right join, my left table and my right table combined, you may not always get the results because I'm searching against something specifically for my right table. So I'm not going to get results if there is no value in my right table that matches the left. So this is where you start really having to pay attention to what's where your join clause is, what tables you're filtering, and how you're joining the two tables together. Any questions about that? Because like I said, joins are really crucial to understanding how everything works.
We have a general question here. Is it a possibility to have duplicates using an inner join?
Duplicates, it depends on what your data is. I think I need to know more what you mean by duplicates. If your data is duplicated and you're joining across, then it could look like there are duplicate data in your data sets being returned. But this is where I'd want to look at what your data is and understand it better to see what that means. You could have cases where you have multiple rows that meet the criteria. Let's say table A has 1 record and there are 2 records in table B that meet the criteria for table A. You could have 2 rows, so it looks like the data being returned from table A is duplicated, but it's not because the data you're pulling back from, it has 2 records that match it in table B. So that's where I would start looking at your data to say, is it really a duplicate, or do I have multiple rows that are associated with that first record?
Great, so we have a classic, it depends. Love it.
Yes, we have our classic, it depends. But this is where it's knowing what your data is and really understanding which data am I pulling back and figuring out that information. So yeah, classic, it depends. So let's go on to the next few things quickly. Group by, having, and order by. So I have this new table that we'll start working with our sales order. And just so you can see a little bit of information about it, I have 21 rows, randomly created data. Basic information. We have accounts, contact person, total amount for the sales order, amount due, basic information. So I want to see total amount and amount due for all sales order for each account. So this is when we start introducing aggregates and why you may want to use a group by clause. So I'm doing a basic inner join between sales order and account. I need to know the account name because I want to see the account name. I want to see the totals for the total amount and the total amount due. So I'm using a sum, my aggregate. And anything not in my aggregate is going to be in my group by clause because this says, how do I want to roll up my data set to get that aggregate information? So run that, I have 7 rows. I have 7 accounts, and each one of those accounts had sales orders. And so now I can see that how much everyone owes and how much they owed all together. Now I want a little more information. I actually want to see just those where they owe, let's say, more than $500. So it's the same statement as before. I'm just simply adding a having clause. So notice I have everything grouped up, and now that I have that grouping, I can now do with an aggregate, and I can actually use that aggregate in my, it's not a where clause, it's a having clause, but it will act as a where clause because I'm filtering out what's being returned. And only 5 rows owe more than $500. only 5 accounts. So now I want to take that and I want to see those in a given sort, a particular order, by the contact's last name. So now I'm adding another column to my join, the person, and I'm joining them to my account table. My group by is the same. Well, actually, no, it's different because I want to see 2 other pieces of information, the first name and the last name of the person. And you can see they're also here in the select. They are not part of any aggregate. My having clause is the same, and now I'm adding a simple order by. And when I run that, we can now see that 5 rows are returned because there are only 5 accounts. And now I can see that they're ordered nicely by last name. And you don't need to use group by to use order by. You can use it without. You can also say the sort order that you would like things in. For example, descending. Here I want just those orders where amount due is less than 200. And I want to sort by the amount due descending and the last updated descending. There are 10 rows. And we can see that now I can see the amount due is descending. And within that, we can see a descending last updated. And of course, you don't have to have the order the same. If you have multiple columns you want to do a sort by, here we can do the same thing, except for amount due, I want ascending, because if you don't specify, it's ascending, and last amount descending, or last updated descending, excuse me. And we can go here, and we can see amount due is now ascending, but within where the amount due is the same, we can now see last updated is descending. Any questions about that?
Nothing specific to that, but all of us are wondering if you're going to share this wonderful notebook with us along with your slide deck.
I will be sharing these demos. I will share the notebooks, and I will also share versions of this for Management Studio if you haven't started using notebooks. Like I said, I decided to do notebooks for this. This is my first time using it, so I'm actually kind of excited to how it looks and how it works. So definitely need feedback on that.
Awesome. Thank you.
All right, so we've got 3 more things to cover: insert, updates, and deletes. So I'm going to jump back to the slideshow. And the good news is we spent a lot of time on selects. So hopefully, if you can write a select statement, you'll see how this applies to insert, updates, and deletes. So there are 2 ways to write insert statements. The first way, we assume we know all the values. So it's insert into table and our values and our list of values. And the other one directs the output of a select statement. So if we look at what's same, it's the insert into table. It is table singular. You can only specify 1 table for your insert into. And then we have a column list. We need to know what columns you're inserting into. If it's not there, it assumes all columns on the table, and you may not be able to insert into all columns on your table. Or maybe you forgot there was a change to the table, so you really want to be specific about which columns you're inserting into, because that column list between your values or your select statement must match what you're inserting into for the table. So the first insert statement value is a list of values, usually constants, could be variables, but it's a known, essentially you know the values that you're inserting. And then this other part should look really familiar because we just spent our time talking about that. It's just a select statement. And it's literally taking your select statement and saying, I want it to go into this table. So it's pretty simple. Again, you can write a select statement, you can write an insert statement. So now let's talk about updates. There are 2 ways you can write an update statement. The main difference is one is a standard SQL, ANSI SQL statement. And I say all SQL databases, but it's really all relational databases that you can write SQL statements, so Oracle, MySQL, so on and so forth. The other one is T-SQL specific, or Transact SQL, Microsoft SQL Server specific. So what's the same between these 2? It's really that set columns. So it can be a list of columns, and it's going to be either a constant value or it can be another column name. So you have your options for what that is. The next is update. This is where you start getting the variation. Update table or table alias. Note it's singular. You can only specify 1 table for your update. And then a where clause. It's a little different between the 2. The first one, the where, you'll notice it doesn't have a from clause because it assumes that the from is the table that you're updating. So it's not dealing with multiple tables at once. The transact SQL, that it's from table where conditions. So essentially, it's your select statement. It's that bottom half of your select statement that you're using when you're writing your update. And then you have a delete. And the delete, there are also two ways you can write a delete statement, very similar to update. You have a delete from table where conditions, or delete table or alias from table, singular or plural, where conditions. Again, it's similar for the update, where one is all relational databases, the other one is transact SQL specific. Now, if we note what's the same between them or similar, we're talking about the from table where clause. It goes true with pretty much everything we do, but especially once you start getting to updates and deletes, that where clause is your best friend. If it's not there, you could accidentally delete everything from your entire table. If you have a million records and you only meant to update one, it's bad. Deleting anything that you didn't mean to delete is bad anyway. So always really make sure you have your where clause and you know which records you want to delete and how many you expect to be deleted. But the big difference you'll notice between these two is the first example, it just says singular table. The second one, it means plural. So we can write it in such a way that you're using joins as part of your delete statement directly. And that's where this delete part gets, where the difference between that. Here we just have delete from table. The second one, you need to specify the table name or alias. So if there are multiple tables in a join, just like the other three statements, you can only specify one table. Here too, you can only specify one table as the target of your delete statement. The other thing to notice, there's no column list because we're not deleting an individual column, we're deleting the entire row. So there's no column list involved at this point. So let's go through some examples, starting with insert. So first we're going to do some inserts based on known values. So first I want to confirm this person's ID. So I have one row, their ID is 4, and this person happens to work at Hedera Beauty. So I'm going to write my insert into my table. I'm listing 2 columns. One of them is an identity, so I can't specify a value for that. The other one is it's a nullable field, and I actually don't have an alternate contact person ID, so I'm only inserting the values that I know. One row, and now I'm going to confirm that my account now exists. One row returns. Whoops. There you go. So now let's talk about multiple known values at once. So my currency table, I had 6 records. I have 4 currencies I want to add. And this is the syntax that I usually forget about, where I have known values. So I can group them all together and I can insert 4 records at once. And so now I can confirm my currency table now has 10 rows. Pretty simple. So now let's do an insert based on a select statement. So, not sure why that's commented out, but first let's select the data we want to insert. So I have this person, last name Prince, I have full name, person ID. So now I want to say they work in Amazon. So I need to insert a new account for Amazon. Now remember when I said if you can write a select statement, you can write an insert? If I go here and comment out my insert, I just have a select statement and I can run it and I can see exactly what it's going to look like. Those 2 values that are going to insert. So now I can uncomment it, run one row affected, and now I want to confirm both accounts that I've just created are there, and I have 2 new accounts. So let's quickly create some data for them. I'm going to skip this select because we're going to show it down below, but essentially I'm going to create some sales orders for these 2 accounts. One thing I will point out is I'm doing a left join, but notice my where clause. I'm saying where a not null field is null. So now I'm using my left join to say what data is missing, and I can use my where clause for that. So before I do my insert statement, this is the same query with less comments. And again, you'll have it. Where did it go? And I'm still not at the right spot. So if I comment out my insert and run this, this is going to be the data I'm inserting. So 2 rows. So I now have sales orders. So if I uncomment my insert, I have 2 rows affected, and I can now confirm that I have those 2 rows. Any quick questions on inserts?
I think we're good, Deborah. We've got just a few more minutes.
Yep, I'm going to try to do some of this a little quickly. So this always takes much longer. So updates. So I have an account. If y'all have noticed, I've been using comic characters from Marvel and DC Universe. So I have my account. Some of you may notice I had an account name of Marvel. I want to update that to Shield. I ran this. I have one account. So just because I have to confirm these things, one record, update, one record, and now my account for Marvel is now Shield because this is known data. So now we can do the same thing for multiple columns. You probably noticed that my person, Selena Kyle, I had the first name and last name reversed. So now I'm using my update. Notice I'm using a table alias since I'm using a table alias here. I know his full name is here, and now I can update my last name to first name and first name to last name. And now Catwoman's records are correct and she won't be upset. So now we can do multiple records at the same time. So I had an issue where in my data, I had a lot of accounts that I created where the amount due, I set to total amount, but I meant to set that to 0. So here, let me fix that. With my update, I'm saying using the table alias, amount is a known data, and my last updated, I'm setting to today's date time. I have 6 rows. And you can see those here, amount due is 0. And then the last thing is I had a whole bunch of records that I wanted to fix in a random way. But instead of doing that sample up here, let's do this one. Because again, if you can write a select statement, you can write all the others. Actually, let's do this the easier way, where this is called a block comment. We can see my select statement. And so I can confirm that what I'm about to use for my update is correct. I have 12 rows. This is why we don't type in demos. And I can update, and we have 12 rows affected. So now we can see that I'm using other columns and calculations to update multiple records at once. And so let's quickly go over to delete. So first, it's a known record. I had 10 currencies, and ID number 8 I added, and I really don't need it because I don't like delete without confirming how many rows. I can now delete, and I can see 1 row affected. We can do deletes based on other tables. So let's go for here. So I want to start looking at accounts where information needs to be deleted because they no longer owe anything. So I can now do a select statement. I know Amazon no longer owes anything. And so now I can delete those records. Again, it's very similar. Notice my from clause and the from clause for my delete are the similar, but notice I'm using a table alias here. So that way I know which table I'm deleting from. So I can see 1 row affected. And we can do this for multiple rows with a little more complex. So again, if you can write a select statement, you can write a delete statement. We can now see my select statement. So I can run this, I can confirm that I've got 6 rows I want to delete. So then I can go back here, change my delete, I can specify which table I'm deleting from, and 6 rows affected. Any questions on that?
I think we're good, Deborah. We're getting a little short on time.
That's because the good news is that's what I had. We're at the end. Made it just in time. So, because really what I'm going to tell you next to do is practice and get a local database set up. SQL Server Development Edition is free, so you can install it locally, play with data. I will tell you to start simple and work complex because you'll notice my queries got that way as we went along. lots of examples, and even bad SQL you can still learn from. So definitely look at SQL statements, figure out what those pieces are. There are a couple books that you can use as references, and user groups, virtual user groups, conferences like these, SQL Saturdays. There's a whole host of events where if you keep going to them, you're going to see more examples of how this works, and you'll get better at SQL by going through the different examples. So if you have questions, let me know. I'm on Twitter, I have a blog, and I will be posting all of these examples later tonight. And just thank you all so much for coming, and thanks for having me, and to Redgate and to all the organizers, and to you, Monica, for moderating.
Awesome. That was really great. You are a fantastic storyteller, very simply to walk through and understand exactly what you were talking about. Really great feedback, and it was really good. Many people said that they're looking forward to watching it again and again and again and again. It was so informative. So really great job.
Thank you. Oh, thank you all so much.